My name is Asma from the CEA at France, and I will present you my paper entitled From Research to Practice, Does AI Promote or Prevent the Use of an MBSE Tool? So I will start by presenting my company. Yeah. So the CEA is the French Atomic Energy Commission. So it is a public research of excellence, and it figures among the top 100 global innovators in the world. So we are working with industry and research laboratories together. So here is some examples of international industries that we work with them, and we have also some research activities. So our mission is a multiple. So we work at the energy domain, at the economic domain, a defense domain, and we have 4 a departure, and I am working on the technology research one, and especially in the smart digital systems one. So this is a brief introduction of the CEA, and this paper is about the program Augmented and Digital Systems Tools, Augmented Engineering in the Digital Systems Tools. So we come back to the paper. From research to practice, does AI promote or prevent the use of an MBSE tool? So to understand better this title, we should understand what is an model-based system engineering tool. So model-based system engineering is a kind of a system engineering. So the system engineering is an interdisciplinary approach and means to realize successful systems, and it focuses on defining the customer needs in the early phase of the development cycle, and documenting those requirements and then design the system. So it is just like the a classical cycle tree. So the model-based system engineering is a kind of system engineering that is based on models. So why models is mainly to reduce the amount of time and to raise the level of abstraction. So the designer are more focused on the system complexity and the system functionalities rather than the development platform constraints. So to use this approach, we need a tool that implements it. So in our laboratory, we have implemented a tool called a Paris, which is a model-based system engineering tool. So Paris is an open source tool, and he complies with several OMG standards, object management group standards, like UML and CSML and moreover. And he cover all the V cycle systems, starting from the requirements to the automatic code to the execution of the models after the automatic code generation. So this tool has some success stories because he has used by several industries to manage the complexity and to improve the team communication, to improve the requirements traceability. But it has also several problems, mainly due to the user interface, and that the modeling languages are also complex to understand. You know that since a few years, all of us are talking about AI, artificial intelligence. So the paper tried to answer this question: what role can be played by AI to enhance the adoption of an MBSE tool like a Paris? So this is the agenda. I will present some related works, the proposed solution and the implementation, the evaluation with a case study, and I finish with a conclusion and some perspectives. So we can embed AI techniques in several steps of the system development process. Starting from the concept of operations. Operations here means the functionalities of the system through requirement specification, design, implementations until the test phase. So for example, for the concept of operations, a lot of work are using AI to define ontologies, knowledge bases, and so on. For the requirement specification, using the natural language processing techniques like clustering, machine learning, and so on. To translate requirements to the design, also there is a lot of work using AI, and even for the design phases, some researchers or developers are introducing what we call recommender systems in the design phase. So the tool will help the designer to build the design by helping the designer a response to some questions, how to design, for example, a system that was already designed by someone else. So the tool will help the user reusing all designers. Also for the implementation steps and so on. So the idea is to see if embedding all these AI techniques are good or not for the use of the model-based system engineering tool. So what we have found, according to our experience using those kind of tools, that okay, if we add AI technique to build ontologies and to define concepts, it is a good thing, but the design still be built by hand, and the design is the more difficult step in using those tools. Also, if we add a commander system, the designer, you know, this kind of system, the chatbot, for example, are not always a welcome tools in if we are using a tool for a time, and if we see some other component like a chatbot, now everyone will accept this kind of system. So there are ethics risk, and also those kind of system, because they come with a user interface, and it can cumbersome the tool. So also using the AI to generate the code, for example, C or C++ or Java code from the design, this is a good thing, but this step is not the most used step, because the code is not really 100% generated from the design. We only generate the structural part of the code. So this can also cumbersome also the tool. So we think that the most convenient step to embed AI is in the first and the second step of the V cycle. So in the design and the analysis of requirements and the generation of the design from the requirements. So our solution is to propose an approach, and this was already published in one thesis. So the link is above in this slide. So the approach consists of analyzing the requirements that are written in a natural language, and generating the design from those analyzed requirements using AI techniques. So this is the approach, and we have implemented it using some open source tools. So for the ALM tool, application lifecycle management tool, where the user can edit his requirements. The example is the Tulip tool. It is an open source tool. For the AI techniques used to analyze and to process those requirements, we have used Lima, which is also an open source pre-processing tool, and some Python libraries to classify and analyze those requirements. And for the design generation step, we have used also an open source model transformation tool. So if you are interested in more details about these implementations, the PhD thesis contains all the details, and also a paper that contains some details. So this is an example of a case study where we have some requirements written in the natural language. Here it is not, it is what we call a pseudo natural language. So for example, as for the first requirement, we have also the same syntax as a user. I want to, and after we describe the functionality. So it's not really a completely free natural language, but it is a pseudo natural language. So the requirement should be compliant with some pattern to be well analyzed by the tools. So what we generate here is UML use case diagram, and we can see here that we can generate automatically the actor, the use cases, and the associations. So for the evaluation, we use the classical criteria, the precision, the recall, and the F-user, and also the execution time. And we find that our approach is a good one too, and can be comparable to the use cases that are built from that are built by hand from the legacy design models. So to conclude, in this paper, we have studied the impact of the embedding AI techniques in an MBSE tool, a model-based system engineering tool. We conclude that the most interesting step to embed AI is the requirements analysis and the generation of design model. We have proposed an approach using natural language processing to analyze the requirements. We implement this use case using Tulip, Papyrus, Lima, and AI NLP libraries. And we got some encouraging results for the generation design. So for perspectives, there are a lot of perspectives when we like to embed AI in our systems development. So in our laboratory, we are interested in working in the trustworthy AI. So how can we trust the AI when it is embedded in our systems, and how can we explain the AI decisions if it is embedded in our systems, and so on. This is our perspectives to work on. So thank you very much.